Today we'll be doing a soldering tutorial, and today we'll be building the Bulldog Amplifier. So let's get started. First off, you'll need the Bulldog Amplifier pieces and parts with the PCB and the parts included. You'll get this when you visit Fair State University, the engineering building, either the electrical engineering technology or computer network and systems department. You'll receive one of these if you go on a tour, and you can go home and put it together. So I'm going to show you how to put it together. You also need a soldering iron with stand and sponge, a little bit of solder, preferably lead free, and wire cutters. And I also recommend a third hand tool, although this isn't required. Definitely helps when you're trying to hold the PCB and solder components with just only two hands. So definitely recommend that. Also, if you plan on using it and testing it, 9-volt battery and 9-volt battery clip, and also some type of speaker so you can listen to your amplifier. And of course you're going to need some kind of input device like an iPod or tape player or something like that. So let's get started. You'll receive this in this static safe bag. First you'll notice there's a bunch of leaded components, and then here's the PCB. Notice it's the most small amplifier, version 1.3. So this is made by one of our professors here, Professor Most, and as you can see on the top, Fair State University Electrical Engineering Technology program. So this is pretty well built. It's got all the silk screen of all the components on the front, so it's pretty self-explanatory in that respect. And then you'll solder to these different pads on the back. So we'll get started. First thing you want to solder is the smaller components, so maybe the diodes, the resistors, okay, the really small things like this. So first off we'll solder the diodes. So there is, let's see, there's 3 diodes in this package here. They are all the same. Okay, you can see the diode symbol right there, D2 and D1 over there. They all have the same markings, so all 3 diodes in the pack are the same. Notice on the silk screen it has a band on the left side here. Okay, that's so you orient this the correct way. So you're going to want to orient it like this, with the black band corresponding to the white band on the PCB. Okay, you don't want to do it the other way, otherwise it won't work. So first off I'm going to bend the leads of the component. Insert them through the PCB like that. Okay. And then looking on the back side, you can see how they poke out, protrude. And what I'll do is I'll bend them to either side like this, so that the component doesn't fall out when I turn it over like this. All right. So I'm just going to show you one of these diodes. And I have it flipped over. I'm going to put it in my third hand tool. This is the point where we actually get to soldering. So you're going to want to have your soldering iron all heated up. Make sure it's clean. If you haven't already tinned it, make sure you tin it. That involves just putting a little bit of solder on the soldering iron like that. Do that for new tips or new soldering irons to keep it clean. So I just did that. Use your sponge to remove any excess solder. So first off, what we're going to want to do for proper soldering is actually put the iron in between the pad and the lead here. So we're going to put it there, and then we're going to apply the solder. Don't put the solder on the iron and then put it on the PCB. That's not good practice, and it won't usually give you a good solder joint. So I'm going to put it right there, and that's it. Just heat it up, apply your solder, let go, and you're done. So there's our first diode. I have all three diodes soldered in. I'm going to take my wire cutters and cut these leads. Now I'm going to want to cut these leads right above the solder joint. Okay, just like that. And do that for all three diodes. Each has two terminals. Now that I have that done, I can move on to the next component. In this case, I think I'll be doing maybe the resistors next. So, there's many resistors in this kit. Looks like there's looks like there's 8 of them. So there's all 8 of our resistors. Oh, scratch that. That's 9. So we got 9 resistors, and I'm going to show you how to read the color code on them, because on this board here you can see it has like a 1K value for R5 up here. But if you don't know which one of these is 1K and put it in the wrong spot, it's not going to work. Okay, so here's the resistor color code. So if we're looking for a 1K ohm resistor, which is the one I just said, the first band is the first digit. So in this case of this resistor, it'd be green. And then the second digit is the second digit in the value, in this case blue, which would be 6, so it would be 5, 6. And then the third band is the multiplier, or the number of zeros. So red has 2 zeros added on, so it would be 5, 6, 0, 0, or 5.6K. And then the fourth band here is just for tolerance. Okay. In this case of the gold, it's plus or minus 5%. But we don't really have to worry about that. We just need to find the right resistance value. On the resistor I have here, notice the first band, it's really hard to see, but it is brown, then black, then red, and gold. So if we look at our little chart here, we have brown, which is 1, black, which is 0, so we have 10, then the multiplier is by 100, or 2 zeros added on, which is 1000, which is 1000 or 1K ohm. So this resistor we have here is our 1K ohm resistor. Brown, black, red, and then gold. So with these resistors, notice I'll put one in R5 there. Notice with resistors, there's no identifier to put them in this way or this way. Okay, so they're not polarity sensitive. So it doesn't really matter which way we put them in. Okay, so we got that one in. Let's look at the one down here, R6. So R6 says 510. So for 510, we're looking at green, brown, and then that's 51, but we need 510, so we need green, brown, brown. So looking at our resistors, find the one that is green, brown, brown. So again, we'll bend the leads and put it in where it says to. Once again, it doesn't matter which way you put this in. So now we got 2 resistors in there. Notice there's one up there that says 1 k ohm, so that's the same color as the first one we did. Then right below it, it says 1 m, which stands for mega, so we got 1 mega ohm resistor we have to find. So if we look at this, we're going to have 1, 0, brown, black, then we're going to need multiplier, and the multiplier is going to be times 100,000, so 10 times 100,000 is 1 million, or 1 mega ohm. So we're going to want brown, black, green. Okay, and there's our brown, black, green from the kit. The other things we have is a 3.3 mega, got a 1 and a 1 over here, a 33, and the 1K I already mentioned. So we're going to look for the 1 and the 33M real quick. So for the 1 ohm, our first digit's going to have to be 1. Okay, and then our second digit's going to have to be 0. So it's actually 10. So the multiplier actually has to be a division rather than a multiplication. So if we look down here, the third band is actually going to be, or it has to be, gold, which is a divide by 10. So instead of multiplying by these numbers, we're going to divide. 10 divided by 10 is 1. So we got brown, black, gold, and gold for the multiplier. So that's what we have right here. Brown, black, gold, gold. So that's one of our 1 ohm resistors, which is going to go right here on the board. Okay, and there's going to be a matching one over here as well. Notice we also have a 10K up here I forgot to mention. So the 10K looks just like the 1K, except it's got a slightly different multiplier. Okay, it's going to be brown, black again, which is 10. Then we're going to have orange, which is 1,000. So 10 times 1,000 is 10,000. So the 10,000 one goes right here. Just like that. So we have the 33 ohm and the 3.3 mega ohm. So looking at our chart, the 3's are orange, so let's do the 33 first. So we have 3, 3, so that's our 33, and then for the multiplier we want to multiply by 1, so we get 33. So it's going to be orange, orange, black, gold. So that's this one right here. Okay, so we got that one in. Then I'm going to show you the 33 mega ohm, or sorry, 3.3 mega ohm. So again, it has two threes, which is orange, and then since it has to be 0.3 mega ohms, we're looking at green as a multiplier band. So 33 times 100,000 will give us 3.3 mega. So that's this little one right here, and that one goes right above this diode up here. And notice now I have a bunch of leads, so I'm going to solder all these up and then trim them up before I finish the rest of the resistors. So now I've soldered all those resistors in and clipped the leads. So now all I have left is the one remaining 1 ohm resistor, as well as the other 1K resistor that we didn't put in before. The reason I didn't put all of them in is all these leads were kind of obstructing my view, so I did it in 2 batches. I could have spread it out a little more evenly if I wanted to. So there's our 1 ohm, and finally our 1K ohm, which is a pretty standard value. You'll get to know that. Brown, black, red. Okay, so this time I'm going to show you these two resistors getting soldered in, because it's a little easier to see than the mess I had earlier. So clean off our tip, put the iron on the pad between the lead and the pad, just put a dab of solder in there. See the solder flow onto the pad. After that, the component shouldn't move at all. Then we're going to clip the leads. Right above the joint we just made. And that's it for our resistors. So the next thing we're going to do is, why don't we do the transistors, because those are quite small. So for our transistors, looks like we have 6 of them here. These are all of our transistors. Notice the big square ones go into either or of these connections right there, so we'll do those 2 first. Okay, and notice their label is 2N4923, and then they have a little dot on the left right there, which corresponds to how this is supposed to set in there. So it's supposed to set in just like that. Okay, and then we'll bend the leads back so they fit just like that. So on the back side we're going to have 3 leads like that. I'm going to push them opposite ways, so transistor doesn't move too much. Okay, so we'll solder that one in. We'll do that one and this one identically over here. Okay, and then we also have some other ones like this one right here. Notice it says 2N3906. So we gotta look for 3906, which is this one right here. Alright, and notice it has 3 pins as well, but these 3 pins don't line up with what we have here. So what we're actually going to have to do is bend the middle lead of this transistor back so the 2 outer leads fit in like that. So I'll do that real quick. So with the back lead bent now, notice this silk screen on here has a flat edge. Make sure that lines up with the flat edge on the transistor. If we spaced our holes just right, our leads just right, they should fit right into the holes. However, I did not do it so good of a job. Okay, I finally got it in, so you're going to push it all the way down as far as you can. You can just leave it sitting up like that. And then bend your leads down so it doesn't move anywhere. So I'm going to solder up this one, and then I'm going to place this one and solder it off screen, and then we'll do these 2 transistors and the one up here as well after that. I'm soldering up the second square transistor here, and notice it's got 3 leads, but they're spaced really close together, so you got to be really careful when you solder these not to touch these 3 pads or pins together with solder. So now notice we have both these transistors soldered in, as well as the one up here. Next we're going to do the one over here, which is the same as the one over here, the 2N3906. Then right below it is the 2N3904. So we're going to put those in their respective places. And then we have one more up here. It's the BF256, which is this one over here. So we're going to have to put that up there as well. So make sure you don't mess those up, but they're all the same. Make sure the flat edge lines up with the flat edge up here, same down here, same up here. So now all we have left to do is put in the capacitors, and this is the smallest capacitor, so I'll put this in first. This capacitor is not polarized, okay, so it doesn't matter which way you put it in. This is the 220 picofarad capacitor C5 here, so we'll just put that in there. Alright, and since it's the only capacitor of its kind, we don't have to identify it using the capacitor code, but if you're wondering, it's capacitor code 221. The next capacitor we have here is a 4.7 microfarad capacitor, and with these electrolytic type capacitors, they have to be put in the correct way. They are polarized, so the positive end is this longer end and the negative is the shorter end. And the negative end actually has a little white stripe there, just in case the leads aren't the same length. So we're going to put the longer lead into the plus up here of C1, There's our first electrolytic capacitor. Then before I put these last three capacitors in here, they're pretty large, so instead of soldering those up first, I'm going to put in these little fins here marked speaker and ground. These are going to be our outputs, so the ground of the speaker and then the positive end of the speaker. So you can just attach your speaker with banana clips or solder them on here, or just touch the leads onto these points. So I'm going to solder these up, this capacitor and this other capacitor, and then we'll get the large three capacitors soldered up. These terminals down here are pretty big and have a large pad, so we're going to have to use quite a bit of solder on those to get them to stay. And again, you could just put wires in these holes as well. You don't have to use these fins that are provided. So now all we have left is three electrolytic capacitors. Two of them are 220 microfarad, one is 1000 microfarad. So you can tell just by the size that the bigger one is the 1000 microfarad capacitor, and since these are all electrolytic, they are polarized, so we do have to put them in the correct way. So I'll put in the two 221s first. Remember, the white line means that's the negative side, or the shorter lead, whichever way. So you're going to put the long lead to the plus on the silk screen. Same for the second one. The big 1000 microfarad. Like that. Then we'll solder these up and we'll get to testing this. So right now I got my iPod hooked right up to the speaker I have, and you can barely hear it. So this is hooked directly up from the iPod right now. I do have the power connected on my amp with 9-volt battery clip and 9-volt. You can power it between 9 and 12 volts, I believe, and we have our two inputs here for our signal, and I'm going to hook up the other signal here when we switch to it amplifying. So I'm going to put that up here and hook up the other lead to our speaker. That's the sound. I had the song playing the entire time. Just now it's amplified. I'm going to rewind it a little bit. Notice if I overdrive it, it starts to become distorted. So there's a limitation to how much this can drive, but as you can see, we built our own amp here. So good luck building it, and have a good day.